So welcome everyone to today's live session. Thank you for joining us. It can be good morning or good afternoon, depending on where you're calling from. My name is Kenneth with Digital Africa. I wish to present to you today on the topic on real-time band area mapping. This is quite an important topic in the context of Africa, especially when we have some abnormal fires due to issues of climate change. So Digital Africa live sessions have continued since August the year 2020, and this is the session 181. We do these sessions in English and French. To give you a background of the program, it was set up 5 years ago, and the opportunity here to support all the thematic areas, including land degradation, water resources, and coastal erosion. Access to the platform, as many of you have seen, we have the Digital Africa map and the sandbox. And in today's example, we'll be able to use the sandbox to see about the resources. And also you can access Digital Africa through web map services. And also we have the free online courses. So first we start with the band area mapping using Sentinel-2 data. It's very key at 10 meters, which we have in the platform since year 2017. And in this example, we have the workflow that calculates the normalized band area ratio, where we have a baseline composite image of a pre-fire condition, and then we have a post-fire image. And the baseline of investigation can be 3, 6, or 12 months. So values which are less minus towards the -1 will indicate different values. So burnt areas will have low values and the health vegetation will have higher values of these index. So in this one, we have the normalized band area index from the Sentinel-2 data, where we take the near infrared and the shortwave infrared, and we get the normalized band ratio. Then you compare these values with a baseline, and we have the change in the band area index, which gives us now the indication of where we have incidences. In today's example, we have an example of a place in DBC in West Maprosi, Municipal in Ghana. This one was shared by a colleague who's there and was able to share possible dates of a fire incident, which was witnessed around the 1st of January of the year 2020. The baseline of this example is, for example, 3 months. And here we just define the area of study. We're showing the latitude and longitude, then also indicating the dates. And now we're able to load the baseline data, compute the normalized band area ratio for the baseline period of the year. Then you load post-fire data and also generate a normalized band area ratio for the post-fire image. And then when you calculate that one, we get the difference between the images. We'll be able to get the change in the band area, and we'll be able to have calculation and indication of how much was band area, and your final results will be a GOT file. So having that workflow in mind, we load the baseline data for the particular region, West Maprosi Municipal in Ghana, and you can see the red, green, blue image. And then we have the baseline of normalized band area. And of course, this one will be a date before the fire incident. And then now we're able to generate the normalized band ratio for a period. So in this particular notebook, it has to get access to the fire hotspot data on NASA, fire information for resource management. And this one now you clip it for this particular region. So when you go to this particular website, you'll notice that you need to indicate those particular dates of the incident. You create a query with your email and be able to filter more information. So here we can get the MODIS data and VIS data. And here you just need to do a quick search and you can, clip to an area of your choice. And of course, then archive data is where you can look at different country level data, which is very key for our area of interest. And this one will collect hotspots for particular areas of our choice. So we can clip to different countries and we'll be able to have the results as we show in the notebook. So back to the particular example, having that in mind, this is able to give you the dates and the hotspot data that you require, and we share these on the particular notebook. So when you go to the sandbox, just not to confuse you much, you'll see the particular setup that I mentioned about, having the definition of the plant areas as per this particular literature, and loading the different steps that we are right now. So this particular place, we'll be able to have our location of area, definition of our incident, and load the baseline data. So as we move from that particular example, I'll be able to show you some example of the hotspots, which will be selected by the data that we've received online. And in this particular case, just go into the notebook, you'll be able to see, be able to load the packages that you require. And this is the burnt area mapping, choosing an extent, the baseline of the dates that you've set. And also here is where you have the change in extents. And also the same extents, you can also view them in your digital African map, which is very key when you are working with your different images. So there you can actually load your data just to show you how seamless it is. Then in case you had a shapefile, you click by that area. And so the date of our incident is around first of the year of January. So this one also just takes you to the region as we add all the relevant data so that we can see the relevance of these two images. So in this case, you can load the Sentinel-2 data for the particular area, and we can just click by the fire incident so that we can see if there's not something which was happening. So what we said was around first of around this time. So you can see some image. Then the good thing with this one, you can choose to do a comparison of still the same image. And you could have one before the incident and the other one before. So you could have one just before the year started, or one which is clearly free, free of, so you can actually see some hotspot areas somewhere in the image. You can look at it clearly. Then these I can always share on the chart for you to actually see on your end. So the good thing with the platform is to demonstrate how it is to move from one platform to another, just giving you the scenario. So here it loads the baseline data. So as you can see, it's able to capture an image just before the incident and one after, so that you can have a comparison of the dates. And this is the area in West Maspurika Municipal, just in the border of Northeast and Upper East region. It's around DPC area, so Kunokwa. And as we load the baseline data, we use Sentinel data. You can choose to change the cloud-free to actually, 60% will be fairly okay. You can even use 80%. And as we load, you're able to see the time steps of the data that is returned. In this case, 60%. If you choose to have more, you can see the percentage will be less and less. So as you go through, you're able to conduct the index and gives you the result where we're using the Sentinel-2 data. And then we're able to visualize the normalized burn ratio as a baseline. This is, of course, before the incident. So it should be an image around, December of 2019. Then you load post-fire data. This will be images after the incident. So there'll be images in the January. And you'll be able to see how they are loaded. And then it's the step where we go to the site to download an archive of the data from the set. This is the Modis data. So here you actually you put in your email, and you can create a request or check a request. So you can also choose to create a request. And in this particular case, we are just looking at an example of country level. We are looking at Ghana, for example, and this one will require us to put Modis. Then as you read, you'll see it's an area around the 1st of January. So any image, this one will be okay. And these other ones are later. So for the purposes of this one, you can choose these two. Then you get your results on the shapefile. Then you put your email. Then you'll be able to submit your request. Then it was asking for the dates. So the best part is that we need to have the December before the incident to the 2020. This will be the January to the end of it. So this is where you just go back to confirm the dates of the incident. So this is case by case. You have to be sure the information that you receive So as you can see, it's 1st of January, and that will be fairly okay. Then you can choose to submit, and it will come to your email, and you'll see a couple of requests and when it's ready for you to download. So once you download that data, it's just stored in your, you actually have to copy it here on this folder. So you'll have to look at how to arrange your folders here. So for this particular example, this has been clipped for you. For an example, so you can see you have the MODIS data and the base data, and this one you clip and merge for the hotspot areas. And here is you see the clipped imagery. So this will be a combination of these two for this particular area. And now it's able to help you to navigate to this, to get actually to connect, so that you can actually be able to examine the hotspot of this particular area. So you can see some hotspot areas around this municipality, and then you can extract the data for baseline and post so that you can do a comparison. So the baseline and the post, you can see the comparison looks a little bit very okay and very clear. There was an incident of fire. Then when you look at this MODIS, it will give you a background on what happened there in December towards the event of the fire. So these are MODIS imagery captured hotspots. At least we could have something every 5 days capturing for that year. And then finally, we plot this side by side as a post-fire incident. You can be able to see some hotspot areas, especially in the southwest and northwest, northeast, and the southeast part, based on the values that we see for the fire incident. And then also we're able to capture the delta, the normalized band area ratio, the same area. So this will be an image which was captured after the incident, so the 2nd of January 2020. You can see hotspot areas with the burnt areas. And now from this one, you can be able to apply a threshold just to capture the burnt areas and have a result which is similarly like this. So you have the baseline, the post, and the change in the normalized band index. And also you have the baseline comparison of the RGB image, the red, green, blue, and the posts, and you can see what you are seeing. So this means it's an image in December, and this is one in January, which was similar to something like this when you zoom in. So there'll be one in December, there's one on the 2nd from this side you can see. So that's a good thing with the pairing the Sentinel with the map to actually see if some of the results are similar. Finally, we'll calculate the change in band area index, which will give you a percentage which you can use. And finally, you can export for post analysis or for your plotting and mapping in your GIS environment. So this was on the band area mapping. And now after this one, we'll be able now to look at so that's our results. And the next one is the near real-time band area mapping, which is the new notebook focus for today. This one now adds, we have Sentinel-2, and additionally we have Landsat 8 or 9 to give us more comparison. And now this one applies a threshold, and our result is a vector file, which is a shapefile. So we generate the normalized band area ratio, and also we do the comparison of the indices. Then we add something else on the revitalized band area ratio so that we get more change the fire incident and get a better threshold. So in this particular one, we'd use an example of fire incident in Cape Forest in George, South Africa. And this one was reported on these specific dates of November. And the actual incidents occurred in October, 2 dates, 24th and 29th. So having the baseline information first is useful. Then the latitude and longitude is something you load. And then you'll be able to go through getting the suitable dates, and you're able to load your data. And from that, now you're able to get the dates which were selected. And this is then the band near area, also in the real world examples. So as we load, you'll see you've selected the area, and what you pay attention to is the dates. So this is the 9th of November. So that will be an image just around when the incident was likely occurred, when we had dry weather conditions, and can be a baseline for this particular case. And it has an example of using Sentinel-2 or the Landsat imagery. So in this particular case, when you load and visualize the real-time image, you will get the baseline information. that will have an image just before the incident in September, another one in October, and the other one just before this first incident on 24th October. So these will be the pre-images that you use as a baseline. Then from that, we can actually compare the change in the normalized band area ratio. So we'll have one which was in November 11th, 9th, and the other one which was just before the incident. So this will be the baseline. You can see some of the areas are quite okay, but after the incident, you'll see most of this area was burnt area. So this was quite a big fire, which was reported also in the newspapers. Then once we look further on that particular area, it is further processing on the same. You'll be able to see the change in the burnt area is quite highlighted. This is quite an incident which occurred. So here we are looking at the difference between the image in October 24th and the one 9th November. And you can be able to investigate the incident. And for these purposes, you can work on an area of your interest and you can see how this performs. But the key messages is to know the incidents of the fire before and after, and also what actually happened in terms of either the loss of life or loss of vegetation. So after that analysis, we're able to do further processing in terms of thresholds, like similar to what we had. Then you can see your possible areas are raster-fied, affected by fire. Then from this one, you can do post-morphological processing, just some indices. Then from that, you'll have your final result as a shapefile, which is very key and you can export. So going through this particular notebook, it's quite advanced now. We are using Sentinel-2 and Landsat imagery 8 or 9. And this will depend on the area, of course, of our interest. So this particular area, the fire was early November. That's where we had an image in October and the other one in November to get the incident. And for this particular notebook, you can actually choose. We have the option to use Sentinel-2 as well as a Landsat in case we had the gaps in an image of that area. And as you can see, this is quite a big area which has been captured. And the incident area is specifically for this particular area, which was affected by dry conditions. And so we have the exact date around 12th of November. That's why we had different dates. Then you can choose to work the different indices or time slots. And so you'll see we have images captured before, and the other one which is captured as a baseline in September and early October, and the other ones in October and November. So once we load that, we have the same option of having cloud-free cover at 60% or 80%, and then we have the bands loaded for Sentinel-2 and those ones for Landsat that we require and the different resolutions. And then when we look at the data sets loaded, we can see the types of images captured, at least 5 images on the Sentinel-2. And then when you look at the Landsat, you'll be able to see either there's one image at least captured because of high cloud cover in the region around that time. And then you can look at further, the bands selected and the base images and the post images and the images which are selected. And so then we work closely with the Sentinel, for example, or when we add the option for the Landsat, you see only 3 images at 80% are available. And you have the baseline and post-fire incident. And when we compute the change in the 2 indices, we'll be able to see the image in November and the other one, the baseline. And you can see this is the problem area of the, which was affected by the fire incident. This is the one which will be clipped at the end as a vector file for further analysis or processing. So when you do the changes of the same, you'll have what I just showed you in the other slide. And finally, you'll have the threshold of the area selected, which then morphological testing. Then finally, we can export it as a GeoTIFF file. And finally, we have the rest of file that you require, a vector file that you can export. So these are various possibilities, and also it depends on the area of interest and where we had an incident of fire or not. Then we also have our free online courses, self-paced, and you get a certificate of participation. And more specifically, there is a course on the land degradation, which is very key, where you'll be able to learn some of these tools today, looking at land cover classification at the country level, forest monitoring, bird area mapping using central data, and also we have further step on desertification. And all this is based on the feedback and collaboration we've had with Observation Sahel in Tunisia and the team in Afrigist, where we were able to co-develop these courses, showcasing Burkina Faso and Tunisia as examples. And I know this year we'll be able to work closely with those two partners, especially OSS, on soil organic carbon for the year. So there are many ways to connect with us, such as this live session. The next session will be in French on real-time burning with my colleague Joseph, who's here. And then also we share the recordings of these sessions every week. And very grateful for the partners who've supported this program, especially the Australian government, Helmsy Trust. And finally, this is our opportunity to connect with you every week and just posting in case there's another question, and just taking you through the platform. You can see on our website how to access our live sessions every week in English and French, and also the resources, the platform, as well as the training as well. You can see how to connect with us, submitting a request, as well as where to get the user guide, and of course, where to set you on the sandbox and the map phase, and also making sure that you can share some of your work with us, and we'll be able to share a blog with everyone so that everyone can see your amazing work, especially the work we've done in different countries, making sure we connect everybody. So thank you so much for connecting with us and pausing for any question.